Good morning, good afternoon, some of you. I'm Clive Cook, co-founder and CEO of Precursor SBC. I quote from one of the conversations we had during our contract with US Space Force. Space weather capability is 50 years behind where terrestrial weather capability is today. Precursor is a commercial company focused on providing actionable information in advance of important geospatial events. We provide real-time, high-fidelity space weather mapping. This is space weather nowcasting. This first-of-a-kind capability provides actionable information on how the changing space weather environment directly impacts space-based and terrestrial assets, operations, and plans. The capability we're presenting today was born from the ionospheric monitoring and surveillance innovations we developed for commercial earthquake forecasting. Space weather is dynamic, uncontrollable, and extremely variable over the course of any given day. Space weather adversely impacts operational performance and mission assurance. I want to recount two actual space weather situations. In the first situation, an ongoing aurora event disrupted tracking and communications to surveillance aircraft and interceptors monitoring adversary incursions over Northern Europe. And the same space weather event caused positioning errors for commercial aircraft flying from Europe to North America. Space weather severely impacted performance. In a second situation, throughout a multi-day war games exercise in the Baltics, the ionosphere was changing constantly, disturbing ISR satellite communications and operation. Space situational awareness was blind. In both situations, the space weather environment directly impacts the performance of the space asset operator and space warfighter. In both situations, the need for real-time space weather situational awareness is palpable. Screen is frozen. Okay, my screen is frozen. Can you? Uh-oh, I'm frozen.
It's all right. Keep telling us the story. Keep it going with the pitch, and we'll get on with the slides in a second.
Okay. Do you want to put yours up? Your version up? The same version as mine.
It's okay. Roll with it. Well, you've all work on getting up the slides. Well, in the meantime, just keep telling us the next slide as if it was showing.
Okay. Current space situational awareness solutions fall short. The space weather environment analysis shown here, not shown here, is the actual daily space weather report. Is a static report using an imperfect, non-representative depiction of the ionosphere. There it is. Due to over-reliance on models and outdated sensors. It provides generic information about global phenomenon with almost no assessment of how the space weather environment will impact space assets, operations, or planning. This is space weather reporting 50 years behind space terrestrial weather reporting. This snapshot of the space environment is useful for rerouting assets and communication pathways around dangerous weather areas. It cannot inform operators of hourly or minute-by-minute changes. They cannot anticipate human interventions into the ionosphere. A space weather model does not tell the warfighter or satellite operator or electric grid operator what they are experiencing at any given moment. What if the space weather meteorologist, warfighter, satellite operator, electric grid provider had the capability to monitor in real time the space weather environment with high fidelity and to assess its impact on assets, operational performance, and mission assurance? Next. Great. Precursor has developed a unique 4D time plus volume space weather technology, space weather nowcasting. It's not a model, it's what's actually happening in real time. This first of a kind capability takes advantage of new and existing satellite systems and sensors to assimilate all perspectives in real time using a sophisticated machine learning technique to deliver a 1,000 times gain in both spatial and temporal resolution. The video here presents the actual real-time space weather conditions. We create a real-time map of the ionosphere by measuring hundreds of different perspectives of the ionosphere from GNSS, LEO, ionoson, radio occultation, specialized sensors, and radar systems. You can see each of these data points gathering data points that are and satellites as their orbits cross the sky. Space weather nowcasting captures the real-time evolution of the ionosphere and uses an innovative and state-of-the-art AI-based data fusion capability to deliver unmatched dynamic space situational awareness. With this ionosphere information over a specific area in real time, we can directly determine how the changing space weather will dynamically impact the warfighter, satellite operator, commercial aerospace at that important critical moment in time. Next, please. This operational space weather platform is one of the most effective dynamic space weather solutions in the world. Precursor is seeking a PEO for a space weather focused SBIR2 and is raising $3 million in a Series seed round to advance the company to the next milestones and begin commercial launch of our data subscription services. Thank you for your time. Sorry about the video.
We're all good. Thank you so much, Clive. We're going to open up the floor to questions. Just for moving forward, anybody who has their first question can jump right in. And to make it easier for anybody else who has additional questions, raise your hand and so we know how to get to you. Any questions for Clive?
I have a question. This is Bob Christopher, Mitsubishi Chemical. So Panasonic has a technology for weather forecasting. They use it, they have a sensors they attach to commercial aircraft that collect the data real time as the planes are approaching and landing in airports. So they collect more regional specific data. I guess my question is, how does what layer of information do you add to that, and how does it correlate to those type of weather systems? I guess I'm wondering, where's the gap? What's missing for weather systems that isn't being captured today? I mean, maybe you can explain the correlation between space weather and actual atmospheric weather. I don't know that. I'm just trying to connect the dots in my mind.
No problem. So the atmosphere is made up of multiple layers, right? The lithosphere, which is kind of the ground, the troposphere, which is where what you call atmospheric weather resides. And then above that is the ionosphere. And then past that, you go into deep space. So commercial aircraft fly within that band of ground to maybe as high as 20 kilometers up. The ionosphere, which is where all the satellites sit, where all the communications is facilitated, where different launch vehicles travel into and through, where missiles and radar pass through. That sits from about 50 kilometers above the surface of the Earth to 1,200 kilometers above the surface of the Earth. So the sensors that you're looking at, that they look at to gather tropospheric weather, don't measure. They measure, moisture, air pressure, things like that. What we're measuring in the ionosphere, because the great part of the ionosphere, it's electrically charged, is the electrical energy that resides in that band from 50 kilometers to 1,200 kilometers, and that dramatically affects all, electronics, communication, navigation, guidance, all that stuff. So they're very different and very distinct in their use cases.
Is there a correlation between the two? I'm kind of interested. The reason why I'm asking about this is that Panasonic, where I was heading up innovation, we did a big project around weather forecasting and looking at crops and how to obviously affect agriculture. So we had developed our own solutions, and I just mentioned that with our avionics group. But I guess
certainly some of the analytic techniques would be similar, but the data sets are completely different.
So maybe then let me step back a little bit and say it's a different customer base than I guess you're looking at. So because I'm thinking more about, geographically specific, areas, and in this case, agriculture, but also forecasting weather for different reasons. So that's more topical, more geographic based. So you're more space based. Is that correct? So you're basically providing information to satellite systems and to communication companies. Is that where you're, I guess, tell me what the focus is on that.
Our focus is providing that real-time, high-fidelity ionospheric mapping capability to satellite operators, to national security organizations, to communications organizations, to organizations that are looking for very high fidelity, very high resolution positioning, navigation, and tracking.
Okay.
I just want to give Chad a chance to ask a question, because he had his hand up at the last question. But listen, if we get to this level of questioning, then there's clearly more to talk about. So I think Clive and Bob have a lot to talk about.
Yeah, Clive, my question, you had mentioned one of the potential applications being electric grid operators, or one of the potential customers. Help me understand the value that you're bringing to an electric grid operator with the insights about the condition of the ionosphere. Help me put that together.
Sure. The ionosphere captures or shields us from ongoing and specific solar events that happen, whether it's solar flares or coronal mass ejections, or it's just the daily changes in the magnetic field and energy from space and from the geomagnetic Earth. That directly impacts the grid operators, and was shown many times to overload systems, electric grid systems, transmission lines, distribution centers, and even in some cases, generation stations. All of those, power grid organizations, or organizations which have large antennas, like pipeline companies, like railways, are directly affected by geomagnetic events.